So I teach biology, and I teach anatomy and physiology, and I also teach animal behavior and evolution courses. So I'm particularly interested in addressing some issues around teaching sort of complex modeling concepts, how natural selection works, and how a bunch of things factor in together to result in selection. So simulations are really important for evolutionary research. A lot of what we know about simulation, about evolution, comes out of simulation of, okay, what's going to happen if this happens, and then we go into the lab and test that. And that's true in a lot of different fields, but it's especially true when, for evolutionary studies. And so a lot of courses use computer simulations, which are very close to what's used in actual research, and are great in a lot of ways in that you can manipulate things in fine detail, but often students don't get a really good grasp on what's going on inside that simulation. That actually connecting what's happening on their screen to the numbers that are changing and what the basic rules are that's driving that can be hard for a lot of students. So especially for behavioral evolution, where we're looking at actual behaviors that are affecting how successful animals are, using actor-based models, actor-based simulations, where the students are the actors, can give students a real hands-on feel for what's going on in those simulations. Now, of course, these are going to be a lot simpler than something you might do on the computer, but in some ways that can really help with the understanding of those students. So I'm going to talk about this in the context a little bit of backwards course design, which I think I'm going to explain that in order to explain why I'm doing what I'm doing. So these simulations support backwards course design. They engage the students with their learning, or at least that's what we're trying to do here, and they help students to understand the research in evolution, so not just the concepts, but how people are actually doing this research, because it's relevant to how that's done. So backwards course design is the idea that instead of starting with the material that you want students to learn, you start with, and the activities that they're doing, you start with some really big ideas. So you start with, what are my key concepts and skills that I want my students to remember? And from there you go on to, how will I know that they've done it? How will I know that they have learned these concepts and skills? And finally, only from that, how can I actually help my students gain these concepts and skills? And so when I'm looking at this, I picked a small number of enduring understandings. In backwards course design, enduring understandings are what you want your students to remember 5 years later. Because, whatever your details are, you know that they're not going to remember, most of your individual details, whether that's what muscle we're looking at in the body or what date something happened on in history. They're not going to remember that. What do you want them to remember in 5 years? And so a few that I picked that are key to this evolution question are, the most important thing in understanding an animal's behavior is considering how it affects their evolutionary fitness. Animals use relatively simple rules to decrease the cost of decision making. And animals must be able to respond to changes in their environment, including their social environment. So these are my enduring concepts that I want them to know and understand 5 years later. And so, now that I've got my desired results, I can start thinking about, how am I going to know if I'm successfully teaching this? How am I going to know whether this is useful? And so Well, how can I tell if they've reached them? How can I help them reach them? And this is where these simulations come in, because you can do a simulation that's intended to help them reach the goals and then immediately ask them questions that are going to both encourage that retention and let you know whether you've successfully taught it. So this is combining a simulation with a reflective writing exercise. And one thing I sometimes hear discussed in simulations is like, how do you grade a simulation? And my preferred answer to that is you don't. You don't grade the simulation, you grade what they say about the simulation afterwards. Because I want my students to care about their success in the simulation, and I think they do, independently, because it's game. I've told them to earn points. Of course they want to earn points. But that's not where their grade comes from. And then I also allow the students to revise the simulation to try to improve their outcomes, which gives them a chance to really sort of internalize the rules and think about this. So I've got these enduring understandings that I just want to remind you of what we're talking about. I do a bunch of these simulations during the course of the semester, but to give you an idea of how they work, I'm going to run really quickly through how one of the simplest of them, the first one that I use, works. So they are trying to collect resources from patches, and each individual student is given a role. Now these roles are very simple. They basically consist of one or two simple rules about how they gather things from patches. And as they're walking around the room, there are patches, and each of them is a closed folder that gives them some information, and then when they gather something, they open it up and pull out something that has a number of points on it. So some of these roles might share patches, some might defend a patch. Doesn't really matter what role they have, they're going to follow those rules and try and maximize the number of points they can get while following their rules. So they've got these patches they're collecting from, and each turn they can collect something. They've got a number of turns to go around and try and maximize their success. Then afterwards there's a reflective writing exercise where they're talking about which roles were more successful, which roles were less successful, how did they moderate that. And then they create new roles that they think are going to be more successful than the previous ones they had without breaking the rules of the game. And then only after that can they talk about like what works, what doesn't work, and what does this tell them about decision making in animals. So this is where we end with more conceptual understanding questions. And so those, this all sort of feeds into a cycle of revision and self-analysis of what's going on, whether they were successful. And again, even with their new roles that they come up with, they're graded on how they're thinking about these new roles, not whether their new roles were successful. The students responded very well to these simulations. There were a variety. This was, as I said, one of the simplest. There were a number of these simulations during the course of the class. Unfortunately, I don't have IRB approval to share specific numbers and things like that, but in the course evaluations at the end, one of the questions is, what left the biggest impression? What would make you recommend this course? And the simulations got mentioned more often than anything else. So the students enjoyed it. It seemed to leave an impact in that way. And it also helped, we did some primary literature work in this, and the students, as a sort of a subjective impression, had a much easier time dealing with the models in evolutionary literature than I've seen in any other class where I haven't used this. The ability to grasp what a model is and why you might use it definitely subjectively seem to improve, which is one of my big goals here, so I was very happy to see that. In conclusion, these simulations seem to help with the key points. And while this is very focused on evolution, I think a lot of this could be adapted to pretty much any of these sort of concept models like economics. I mean, a lot of our evolutionary models come out of economic models. So conceptual models like economics or other sciences could definitely use some of these same actor-based model simulations with the students playing the actors.